Hello everyone, my name is Liam, and today I'm going to be going over how to automatically correct movement to move in a straight line for LEGO Spike robots. So, moving in a straight line is a very important programming technique, and this program we have in front of me right now on my screen is the basic way to do that. So it sets the movement motors, sets movement speed, starts moving forwards for 6 seconds, and then it stops. It's very basic. But there's some issues with this simple piece of code. For example, if one of the motors is slightly slower than the other one, setting both of them to the same speed will still result in the robot veering off course slowly. Or, for example, if the robot runs into an obstacle, or it needs to push an obstacle, it can get knocked off course, and it will not correct back and will not go in the direction you want it to. Now, to solve this, we need to use the robot's internal motion unit, which is the thing that tells it in which direction it's pointing. And then, once the robot detects that it's not pointing in the right direction, it will turn back so that it is facing the right direction. So first, we need to get rid of this code. Just move it over here. So we want the robot to be able to turn. Now the block that we use to turn is this one, start moving right 30. But, fun fact, this block doesn't actually necessarily make the robot turn. If you go start moving right 0, you can see it says straight. Because when you say start moving 0, it will actually go in a straight line. And we can use this to our advantage. So, next, what we want to do is we want to get our yaw. So, yaw angle. This will be the variable that we use. But the thing is, we can't just plug it in like this yet, because the yaw angle, it's when it's positive, that means that the robot has turned to the right. But when we say, for example, start moving and then we give it a positive direction, that makes it turn to the right. Which means that really, if we want it to correct and move in the opposite direction to what it's turned, so that it moves back in a straight line, we want it to be the negative of the angle. So what we can do is you can go operators, and then we can get the multiplication block, and we can put it into the variable input slot for the start moving block, and we can say times -1. And then when we put the angle in, it will get the robot moving in the direction that's the negative of the angle. And this program will now have the robot automatically correct back when it gets knocked off course, or otherwise isn't facing at angle 0. Now, if you wanted to have the robot move at an angle that isn't 0, for example, if you have the robot turned 90 degrees and you want to move it to move in a straight line, what you can do to solve that is use a simple addition. So you have yaw angle plus, for example, 90, and then you just put that into the block, and then that 90 gets multiplied by -1 as well as the angle, and this will drive forwards at 90 degrees. It will drive in the direction of 90 degrees, and still autocorrect. Let's take that out for now. And then you might be wondering, well, if you actually try and run this code, however, this will not autocorrect, because this block, this will only run once, basically. If you start the program like this start moving block runs once. It sets the direction that the wheel's turning, and it doesn't continue to do that. So in order to make the robot continually correct, you need it to continually run the start moving block, and it needs to keep on updating its motor power. Now, you could put this block in, say, a forever block. You could just have it move in a straight line forever. But say you wanted to only move a set distance or a set time. Well, like, for example, in our original program, we only had it move 6 seconds. Well, what you can do is you can repeat until. And now this block, it will loop the blocks inside of it until whatever Boolean expression you plug into it is true. And how we can get a Boolean expression that will be true once 6 seconds have elapsed is we can use the timer. So what we do is we get a little greater than block, and then, or really we want a less than block. Or I don't know, it really depends on where you put the variables. And then we want to get the timer, and we want to go until the timer is more than 6. Now the timer automatically starts whenever you hit the button, and it counts up, and I'm pretty sure it's measured in seconds, which means that this program will wait until the timer is at more than 6 seconds, and before then it will continue moving while correcting, and then after that you can just tell it to stop moving. And this is basically the same functionality as our original program that was this, but then once you add variables and make it advanced, it will now autocorrect and it'll be much more accurate. So yeah, I hope that you found this video useful. There's many more ways you can apply these concepts, and I hope to see what you can do with them. Thank you.